We're continuing to talk about lipids. And just as a reminder, what we have done so far, the first thing we did was just describe and characterize what a lipid is. And then I told you that there were two different types of lipids, fatty acids and steroids or hormones. And then I told you that fatty acids were the building block of three more types of lipids. One was waxes, which we talked about in the last section. And then the next type is the triacylglycerol, which is also called triacylglyceride. Those names are used interchangeably. Triacylglyceride. There's a lot of consonants in a row. The triacylglyceride, which is a lipid that is made from fatty acids. Triacylglycerides are what we commonly call fats and oils. So in everyday language, we just refer to these as fats and oils. Triacylglycerols are triesters. You know what an ester is. An ester is a type of a functional group. A triester is a molecule that has three ester groups. And just in case you forgot what the ester functional group looks like, don't worry. I'm gonna show you again, so you'll get refamiliarized with it. If you remember at the beginning of chapter 19, I drew like a cartoon type diagram of what a triacylglycerol looked like. And it kind of had this shape to it where there was one portion along the backbone. We call it the backbone. I told you was called glycerol, this component. And then hanging off of the glycerol, we had three fatty acid molecules. So this is like the cartoon representation of a triacylglycerol. The triacylglycerol molecule is made by literally reacting and combining a glycerol molecule with three fatty acids. So let's draw the structure of the glycerol and fatty acids so we can kind of see what this looks like. Glycerol is three carbons in a row, and the first and last carbons each have two hydrogens on them. The carbon in the middle has one hydrogen on them, and I'm drawing it up and down like this specifically so that we can kind of make it match this cartoon structure that we have. And then each of the carbon atoms in glycerol has an OH attached to it. So this is an alcohol. It's a trialcohol. It has three alcohol functional groups. So here is the glycerol molecule. And then inside our bodies or wherever, the glycerol molecule is going to react with three fatty acids. And even though when I draw a fatty acid, I usually draw the carboxylic acid group, the part that I just drew, I usually draw it on the right side. This time I'm going to draw it on the left side because it's this portion that I'm drawing right now. This portion of the carboxylic acid is the part that actually reacts with the glycerol. So I want to line them up together. And then as you know, fatty acids have these very long carbon chains, which I don't want to draw them all out. So instead of drawing them all out, I'm just going to use our abbreviation R. R is the abbreviation for long carbon chain hanging off the molecule. And to distinguish these three, so these are fatty acids, what I'm going to do is put some little marks by the R's so we can tell them apart. So I'm going to put a prime, which is kind of like an apostrophe, next to the second R, and I'm going to put a double prime, which kind of looks like a quotation mark next to the third. So that notation is the way that we would say that these three R groups are not identical. So these are three different fatty acids. However, in a triacylglycerol, the fatty acids might be the same. They might be different. So the R and the R prime and the R double prime, They may be different or they may be the same. It doesn't matter. Different fats and alcohols have different, or fats and oils have different combinations of fatty acids. So inside of our bodies or wherever this is going down, these four molecules come together, the glycerol and the 3 fatty acids. And when they come together, we get that glycerol 3-carbon chain, and the glycerol keeps its hydrogens, just like we would expect. So I'm redrawing that part. And the glycerol has the single bond to the oxygen. And then instead of continuing with the glycerol to a hydrogen, we now carry on with the fatty acids. If this looks familiar to you, you have seen this reaction, esterification, reacting a carboxylic acid with an alcohol. If it doesn't look familiar to you because you've purged it from your brain, that is totally okay. So this is our triacylglycerol or triacylglyceride. And I'm just going to do a little bit of color coding here. The carbon chain from the glycerol and the carbon chain from the glycerol like that. And then the carbon-oxygen double bond and the R groups or the carbon chains from the fatty acids. And that oxygen that's in the middle, it's not super important that you know if that oxygen in the middle is coming from the glycerol or the fatty acid. Technically, it's coming from the fatty acid. But like I said, that's really not important that you know where it comes from. So don't worry about that. So we have 2 different ways of describing our triacylglycerols, like characterizing them or classifying them. We can call them simple. If we have a simple triacylglycerol, that means that it has 3 identical carbon chains. So it's going to have 3 identical, what we're calling R's in our diagram. This means that it came from 3 identical fatty acids. And then our other option, of course, is if they're not all identical. So then we would call it mixed. And if it is a mixed, it has at least 2, maybe all 3 different R groups, at least 2 different R's on the glycerol, and maybe all 3 of them are different. So this one would be a mixed triacylglycerol would be from 2 or 3 different fatty acids. Now, in everyday language, when we use the word fat and oil, they do mean 2 different things to us. So fats and oils, remember, triacylglycerol is just the fancy way of saying fat and oil. In everyday language, we call these fats and oils. And in the everyday world, when somebody says fat or somebody says oil, they mean something, and you kind of have an idea in your head of how fats and oils are not the same. Although in chemistry, in science, fats and oils are pretty much identical. They are all triacylglycerols. They all have the same general structure. So I'm going to distinguish fats versus oils for you, but just keep in mind that this is really kind of a wishy-washy definition. It's not really easy to classify something scientifically as a fat versus an oil. Fats tend to be saturated, and I'll remind you what that means in a second, but it's just mostly saturated. It doesn't have to be completely saturated. Saturated means, and when we're talking about a fatty acid, a saturated fatty acid is one that has no carbon-carbon double bonds at all. A saturated fat has no carbon-carbon double bonds or very few carbon-carbon double bonds. And when we say very few carbon-carbon double bonds, we don't have a number of what that would mean. Like, it doesn't mean less than 5 or less than 2. So here's where the definition is kind of wishy-washy. Oils are polyunsaturated, which means that they have many carbon-carbon double bonds. But again, we don't have a number to tell you, like, okay, once it hits 10, now it's an oil because it's polyunsaturated. So there's really no actual definition there. Fats tend to be, in terms of their physical properties, fats tend to be solids at room temperature, and that's because they're mostly saturated. But again, this is most of the time, they're solids at room temperatures, but not exclusively. And oils tend to be liquids at room temperature. But again, not exclusively. So again, this is a mostly sort of a thing. And one example that most of you are probably thinking of right now, or several of you at least, coconut oil, which is, we call it an oil, but it is a solid at room temperature. It's barely a solid at room temperature because its melting point is just a little bit above room temperature, but it is a solid. Fats tend to be from animal sources. So our fats tend to be the fats that are in butter, milk, cheese, shortening, which is not from an animal. So there's another. This is not a hard rule. This is not a scientifically defined thing. Oils tend to be, for the most part, from plants. For example, canola oil, coconut oil. Wait a minute. Yeah, coconut oil, coconut oil, olive oil. That's not how you spell olive oil. But then there's fish oil, which is an oil, and it is a liquid at room temperature, but it is definitely from an animal source. So these are just some generalized trends that we see when we're calling something a fat versus calling it an oil. Definitely not a specific set of rules.